Welcome everybody to the course on Dynamics and Control. My name is Pedro Albertos from the Polytechnical University of Valencia in Spain, and the topic of today's session is about the properties of control systems. We are going to see some industrial examples. As you remember, we are in module number 3, which is the control systems properties. In the previous session, we saw some examples of control systems in local, in close situations, like at home or in the cars. And today we are going to have a view on some other examples in an industrial environment. So just remember that when we are dealing with systems, we are interested in the dynamics, which is the dynamic behavior of the systems. And this behavior is influenced by some external inputs, the control signals or the disturbances. And these control signals can be generated by a control subsystem. So the control subsystem, based on the goals and some information taken from the system, is providing the control actions. And the main issue here is that there is a feedback, there is a loop, and then by this we can change the behavior of the dynamics of the system. So where we can find control systems? Well, let's have a look, as we said in our future work. Control is used in many areas of industry. In chemical, in environmental, in automotion, in robotics, aeronautics, on aerospace, in the food industry, but also in energy generation and transmission, in manufacturing, in communications, in transportation in leisure, and in some other basic science like physics, mechatronics, materials, instrumentation, biology or economy. That is to show that control systems is everywhere, not only in nature, but also in any human-made system. So let's have a look at the chemical or petrochemical industry. There are many sub-processes, and in all these sub-processes we need to control the pressure, the temperature, the flow, the composition, the pH. And this is not viewed externally, is hidden, is inside the different sub-processes, but we need to implement this kind of control systems. Also, if we have a look at the siderurgy, producing webs and bars of iron or steel, we need to control not only the running of the whole process, but also to fix the thickness and the quality, the surface, the ruggedness, and every property of the material we want to control. In the paper industry, we have also a number of problems and a number of variables to be controlled. As you know, the paper is previously made with wood pulp and is mixed with water, with a lot of water. And this water should be extracted, and the wood pulp should be extended into sheets and pressed and reduce the humidity. So the end is to get a good paper, and the quality of this paper is based on the thickness, the shape, and the humidity. And all this is achieved by controlling the heat that we are supplying to the dryers, to the pressure, and to the speed of the paper sheet. If we go now to the robotics, we know that robots are more and more used in the manufacturing industry, and they are performing some activities like welding, cutting, painting, assembling. And for all these activities, we need to have a very accurate position and speed control of the end effector, either to weld, to cut, to paint, or to make some assembling. Probably you remember this slide dealing with the tile industry. there is a very big process with a lot of activities, starting from the raw materials in the clay park. This is grinded and then go to the mill, to the dryer, to the press and the kiln. So let's have a look in more detail of each one of these processes. So in the first part, starting with the raw materials, with the clay, the sand and so on, we are passing that to the dosage system and then to the mill. So we need to control the entrance of the raw materials in the mill, and also we need to control the grinding of this material. So we need to control the quality, the composition of the final product, and also the estimation of the raw materials composition which are coming from the storage. The result of this grinding is sent to the press to form the tiles, the original tiles, but this clay slip should be dried. And then we have the atomizer control to then go to the press, and the goal is to determine the humidity and the size of the particles, to dosage the materials and the distribution, also to give the appropriate pressure to the press to make the tiles, and then to, of course, to cover by the glazing if it is the case. When the tiles are, the raw tiles are produced, they should go to the kiln to be cooked, and then we need to control the profile of the temperature inside the kiln, and we need to control the planarity and the curvature of the tiles. And in the end, we need also to have a quality control of the final product and a classification. So as you can see in this whole industry of the tiles production, there are many sub-processes. All of them are connected, so we need to control the overall process, but also in the local sub-processes there are many control activities. If we go now to the aerospace industry, this is even very important, because flying an aircraft is necessary the control, because the flying is an unstable process. So we have provided an automatic pilot, and we need to control the attitude, the speed, the position and the different conditions of flying. It's interesting to remind you an anecdote, which is the first time that we had an automatic journey across the Atlantic, including the takeoff, the flight and the landing. And this was a news appearing in the New York Times in can you guess in which year? Well, this appeared in 1947. That means that there is more than 60 years that we had already a full automatic journey, including the takeoff, the flight and the landing across the ocean. But if we move from the aeronautics to aerospace industry, we have many control activities. To control the orbit of the satellites, to make a communication and remote guide of the different aerospace vehicles, to orientate the solar panels, to guide the robots, the lunar robots, and so on. And all of them require very precise control systems. But if we move also to the food industry, we need very high quality products, and then the milk, for instance, should be treated in a very precise process, keeping the temperature around 150 degrees for 4 seconds for the purpose of sterilization and conservation. The production of wine also requires a very good control temperature, but also the growing of fruits and flowers in greenhouses are more and more under control, to control the size of the fruits, to control the stock of the branches, and also to protect the environmental. So what there is in common in all these activities, in all these control systems? So first of all, we have a process with some input and output. Then we have a sensor providing some information about how the process is behaving. And then we have a control system, which is trying to follow a reference and also to counteract some disturbances. And we can see that this scheme can be applied what we call a servo system or a regulation system. In the case of a servo system, we are not considering much the disturbances, but we are trying the system to follow the reference. And on the other hand, we can have mainly disturbances, and we don't pay much attention to the reference, which is fixed, and then we are trying to make a regulation. Probably you can remember some of the examples what we have seen. For instance, in the case of the robotics, the painting, the welding, the cutting, all these are servo systems, but for instance, to keep the temperature in a kiln or to adjust the pressure in a press is mainly a regulation problem. As we saw at the beginning, we are mainly dealing with unstable plants. Plants like the aircrafts, but also just, you can see here a drone with 4 rotors, and we want to control this moving in the different directions and different positions, and of course this is unstable and requires a control to perform the activities. Let's go to a very simple example. If you see this bicycle, you realize that the bicycle is an unstable plant. If you leave the bicycle by itself, it will fall down. So they need some control to run and to be used. And yes, you can modify the process. You can have this tricycle, and this is much more stable. But of course, if you compare with that, with this bicycle, you can do many more things than with this tricycle. So providing stability by modifying the process could be possible, but probably it's better to introduce the control. In that case, it's the human who is controlling the bicycle to reach more performant activities. The same with the aircraft, for instance. We have this very old aircraft which was almost able to fly without a motor, just by the wind. But this aircraft cannot achieve the same performance that this fighter, which is going very fast, running and moving and changing, turning very quickly, and for that we need, of course, a control. So we can modify the process to achieve some desired behavior, stabilize, for instance, but the control gives to us more facilities to realize, to implement more performant activities. So what have we seen today? We have seen some examples of industrial control systems, regulation or servo systems, and all of them have a common structure, the feedback. And the feedback is, as we will see in the following also, a very important role. And we can change the dynamics of the process, of the system, by modifying the process or by introducing the control. So what is next in our course? We are going to deal with the control system performance. And this will be the matter of our next video. So here there are some of the sources for our slides, and just I want to thank you for your attention.